Hello and welcome to the DevForce 2010 MVVM Light Code Sample Tour, where we'll see how easy it is to build a simple DevForce application and integrate it with the justly famous MVVM Light toolkit. I'm Ward Bell, VP of Technology at IdeaBlade and your host for this tour. Notice the links.ideablade.com/drc-MVVM Light sample. That's where you will find the source code and a written description of what you're seeing here in the video, which is just 6 simple steps. We're going to create a Silverlight application and add a DevForce model to it, as you might have seen before. Very simple. Then we're going to install the MVVM Light toolkit with NuGet. We'll add a DataService class that will help us go out and get data using DevForce out of the database, and also create some design time data that'll help us sketch out our view and see what we're doing. We'll write the view model. We'll update the ViewModelLocator that creates the view model, and then we'll design the view using the design data that we get out of the DataService. Let's get going. We begin with File, New Project. We're going to use the simplest of the DevForce Silverlight application templates. It's a 2-project template. We'll call it MVVM Light Demo. When it's finished generating, it displays 2 README files, which we'll close, and we're going to delete. We'll delete the first one that's in the Silverlight project, application project, and we'll delete the second one, which is in the web project. And now we're going to add an entity framework model, a very simple one. To that we'll add new item, and we'll search for anything beginning with ADO, which gives us the ADO entity data model. We'll call our model model. And the entity framework wizard opens, and we're going to generate from the database. The database we'll use is the tutorial database from DevForce, Northwind IB. It's installed. Small model, we're only going to have one entity type built around the customer table called customer. And the EDM wizard cranks up, and here it generates the one entity type on our canvas, which we close. In the background, DevForce has added some references and generated its classes, its class files, and linked to them in the Silverlight application. We'll just close that up. Select the Silverlight project. That's what we'll add MVVM Light to. We're going to use the NuGet package manager. That's an extension to the Visual Studio. We're going to look at all sources for something called MVVM Light. It searches, finds what we hope is the latest. We ask to install it. And if you look at the Solution Explorer on the right, you can see it busily adding things to our Silverlight project. When it completes here, we close the manager and see that it added 2 MVVM Light references to our Silverlight project, added a ViewModel folder with 2 classes on it. It actually went in modified app.xaml. We'll look at all these things shortly. Had we wanted to, we could have done this in a command line fashion with the package manager console at the bottom here. We add a new class to our Silverlight project, the demo data service, the data service that's going to get our data for us. It's just a class. We call it demo data service because it serves the purposes of our demo. We're not going to need all these usings at the top here, so we'll blow those away. We will need IdeaBlade.EntityModel. We'll be using that a fair amount. So here is a stub for our demo data service, which acts like it's a repository pattern, and this will be used for our so-called production run in our demo, the runtime. We're going to want some design data too, and we're going to make a companion design time repository to get dummy data for design purposes, and we'll call that the design demo data service. We got 2 classes. You get 2 classes. Probably should use an interface here. So we'll have an interface for our data repository. We'll call it, it's got to make it an interface, and we'll call it iDemoDataService. And both of our classes should implement this interface, the production and the design time data service. And our interface has one method in it. It loads customers. That's all we're going to do in our demo. And it has a success callback and a fail callback if things go wrong. That's a pretty standard look for accessing data asynchronously. And so we've got to implement this. We'll put a stub in the production version here and just clean it up so we can see what we're doing there. Make it clear that it has a success and fail callback. Make it really clear, and we're going to need one of these also in our design time data service. And now that we have our stubs, it's time to implement it. We'll start with the production demo data service, and it's DevForce, so we're going to need an entity manager, the custom one, and so we'll create a property for that. And then we're going to initialize it in a constructor. And we'll be using that Northwind IB Entities entity manager, the special one that was generated by DevForce out of the EF model. Now that we'll have a manager to work with, we're going to do a little query in here. We're going to be looking for all the customers. Let's sort them on the data tier, order them by the company name. So it looks a little better. And now following the async pattern, we do execute async. We hope you've seen some other DevForce demos where this is done. And it takes a callback, and we are now going to implement that. You can see why we want to hide all this in the data service rather than show it in our view model. Following the usual pattern, we have to check to see what happened. Did it complete successfully? If it did, we do something good. And if it did not, we do something with the fail path. Now we passed in callbacks, so if it completed successfully and there was a success callback, if null is not equal to success, then we're going to pass the results, the data, back to the success callback. If it did not succeed and we have a fail callback, null not equal to fail, then we mark errors handled and we call a fail with the exception. And that's the standard way of implementing a callback for the execute async, the two callbacks. So we're done with the runtime version. We're ready for the design time version, and we don't have to worry about the success path here. And we're going to create a little method here that's just going to create some dummy data for us. It'll be a list of customers, because this is always going to succeed. It's during design time. So we get a list of customers, and we're going to return it. And now what we're going to do is we're going to create 10 dummy customers that have a name that goes customer 1, customer 2, so forth. And that gets added to the list. But because we'll also be designing a detail customer, a detail view, we want to have the first customer be really representative of what we might see, with a good long name to fill up the space so we know what we're doing when we're designing against it. And now we have our design demos, data service and our production one and our interface. We're ready to go. The MVVM NuGet package added the ViewModel folder and a main ViewModel stub, which inherits from the MVVM Light ViewModel base that gives us some inherited methods that we can use. We are going to fill that out, and we're going to use that data service that we just wrote. And so I'm going to inject that into the constructor. That's the way I like to do it, and hold on to it in the member variable we just added. And then the stub comes with this idea that you could have one set of code for if you're in a design tool, in the design mode, and other code if you weren't. I don't like my view models to be aware of that kind of thing, so I'm just going to remove it and proceed. Our view model will reveal a customer's observable collection that holds the customers we retrieve from the data service. It'll also have a message property. Now that message property has to implement iNotify property changed, and we could use the MVVM Light code snippet here to generate that, which will do, and you can see that it generates an awful lot of code. The most interesting thing about it is what happens in the setter. You really get two choices. One of them is to, when you set, it can raise property changed and also send a message out to whoever's listening, perhaps other view models. Or you could just do it the old-fashioned way and raise property changed. But there's a lot of code here, and I'm just going to back this all out and do it in a traditional INPC property way. Back that out and just paste in the message here, which sets the message value and raises property changed. And then I need another one called current customer to represent whatever the current customer is that the user is selecting. And that too raises property changed as the current customer is changed. So now that I have those properties, we'll go back up in the constructor and we'll initialize the customers with an empty observable collection, and we'll set message to loading because that's what it should look like before we actually get the data. And now we'll go out and actually get the data using our data service, that load customers method that we added. And it has two callbacks, the success callback and the fail callback. So we'll implement those stubs right now, just starting as stubs. So we'll get the fail callback here, and that takes an exception. And then the success path is that the customers were indeed loaded. So we'll create that method. And what we're expecting back is a list of customers here. So we'll call that customers. And so now that we get these customers back from the success path, we're going to pour them into the observable collection. So we'll just do that, add. And we'll also say we'll take the first one if there is one, and that'll be our current customer when we start. And we'll change the message from loading to customers loaded because we succeeded. But if the data service fails for some reason, we'll get this exception, and so we'll set the message to say it failed and explain why. And that's all our view model does. It's got three properties: the current customer, the list of customers, and the message. The MVVM Light NuGet package added a ViewModelLocator to our ViewModel folder. The ViewModelLocator is how we create new view models and how we make them available to views. We'll open that up. At the top, we learn how it is that ViewModelLocator becomes available to the views, which is as a static resource of the application. So if we go look at the apps XAML, we'll see that the NuGet package did just that. It created a ViewModelLocator resource with the key locator, and that's how the views are going to find it. If we look at what the template for ViewModelLocator has here, it suggests that the view models be static references, and I don't see why they should be. I don't like them to be that. I want them to be instance members, so I'm just getting rid of all the static stuff. If I look at our one view model, the main view model, a little squiggly there, tells us that, reminds us that we've got to pass a parameter into it, which is our data service. So I'll create a backing field here, the iDemo data service backing field, and we'll send that to the constructor and make it happy. Now what we have to do is decide what kind of data service that is, and that depends on whether we're inside one of the design tools, whether it's Visual Studio Cider or whether it's Blend. So we will uncomment this stuff, and when we're in a design tool, we're going to set that data service to a new instance of our design demo data service with its design data. Otherwise, when we're running for real, we'll set it to a new instance of our production data service, which is just called demo data service. Then we come down to this main property here, and that has a backing field. I want that to be an auto property that's simpler, so I just did that. This is the main page view, exactly as was delivered to us by the DevForce Silverlight application template. And we're going to modify this view as much as we can using the Visual Studio design tool called Cider, and using the new main page view model that we just wrote, which itself will be presenting design time data for us to draft the view against. First, let's expand the layout grid and design view. It's still going to be auto when it runs, but we're just doing the design. And we'll blow away this Hello DevForce text block. Now we're going to divide the layout grid into 3 rows. So we add some row markers here. And in the top, we'll put a text block to hold our application title. And we'll resize all, which means margins to nothing, and title it MVVM Light Demo. And we're going to position it at center horizontally and vertically. And let's make it bigger. We'll make it 40 here. This should really be done with a resource, but we're in a hurry. And now we'll do the message area in the bottom row, which we'll put a text block again to hold the message that we're going to send and make it fill the available space. Probably needs a little air on the left, so we'll open up the margin here and throw 4 pixels in. Okay, now where are we getting the data? We're not going to type it in, we're going to get it through data binding. So we'll drop into the XAML here for a second, because we're going to get the ViewModelLocator by putting in a data context. Notice that we're binding the data context to the ViewModelLocator under the key locator. It's a static resource in AppXAML. And that ViewModelLocator returns through the main property, the main ViewModel, which itself has been configured, as we saw, with the design data source. So we're getting design data when we design. Returning to the design surface, we're ready to bind the message text block to a message coming out of the ViewModel. We go up and find the text property and click the advanced feature there to get apply data bindings. There's our message property, and when we click it, we see customers loaded coming out of our design view model. We'll put the meat of the view in the middle, that second row. We'll grab a grid, drag it onto the canvas. We'll resize it to fill the available space. Let's divide it into 2 columns. On the left-hand side, we'll put a list of the customers, so we'll have the list box here. We'll drag that in and resize that to fit the space. And now we're going to bind it. We're going to data bind its item source to the customers property, which delivers all the design customers, except as you can see, we're getting the toString on the type, which isn't what we want. We really want something more meaningful here, like the company names. So to save time, we'll switch to XAML, and we'll paste in a resource that I've prepared. Again, you could do this through the designer, but I'm just saving some time. There it is, a local resource, a data template that just has a text block in it to show the company name. And now that we have that, we return to the design surface, and we select the list box. And we go over and we find the item template of the list box. There it is. And we select this resource we just created, and voila, there are our design data as we want them. While we're here, we'll bind the selected item to the current customer property of the view model. This will be a 2-way binding, so that when the user clicks a customer in the list box, that's communicated to the view model as the currently selected customer. Next, we'll put some customary detail over in that second column over there. So we'll go out and grab a grid, drop it in there, make it fill the available space. And then we're going to bind that grid to the currently selected customer in the list box. There, that'll be the current customer, right? And now we'll divide this into labels column on the left and detail on the right. And we're not going to do the whole thing. We're just going to put some representative stuff here. So we'll divide it up into 3 rows and try a few things. Go over to the toolbox and we'll grab a text box to hold the customer name, and don't need a label for the customer name, so we'll make it span those columns, make it fill those 2 columns, and we'll bind the text box to, there it is, company name. You can see it there. And notice we're getting design data, a representative worst case name, so we know what it's going to look like as we change the size. Again, you should use a resource, but we're just throwing 20 in here. And let's make it wrap in case there's something really big that goes in there. Now we'll put in our first label, which will be we'll use a text box for the label, and that's going to be our ID. So we'll just type it in here, not that you would actually display the ID. let's do some layout here. We'll reset this value to auto and set the height to auto as well. And we'll center, well, no, well, first we'll clear the margins out there. Then we'll center it. That looks good. And we'll do something similar down here with our next label. We'll go in there and grab a text block. Drop that in. And again, reset the width to auto and the height to auto. And we'll center it vertically and get rid of all the margins. And now we'll type in the name of the label, which is country. Okay, let's match this stuff up with some data. Let's zoom in a little bit so we can see better. Go back, and there's our text box for the ID, and we'll bind it to the customer ID, which we now see as a GUID. Alright, so we can again reset the height and the width here and see what a GUID looks like. We'll center it vertically to line with the label and get rid of those margins. And it being a GUID now, let's get the margins. We want to play with the width until we know what a GUID's width is, and that looks pretty good. We don't want the user entering it, so we'll make it read-only, and that's enough for that. So now we'll go back and grab a text box to show the country, which will be editable. And let's clear its width. No, we'll do that in a minute. Let's apply the data binding and map that to the country. And now we can see that it's France. So the design data is telling us what a country might look like. So we can now do a better job with heights and width. The heights are fine, but we'll just drag that width to something that looks like it'll hold any country we've got. Blow away the margins. Center it. Looking good. Experience tells me that the user is going to need to change the relative sizes of the list box and the detail. So I'm going to use a grid splitter to separate them and see if I can drop it in here in the right place, which I didn't, and I often don't. So I'm not going to do it that way. I'm going to go into the XAML and blow away the grid splitter that was in there because that's in the wrong place, separating the wrong grids. And I'm going to put a new grid splitter in the right place here. Just drop it in there. And now I'll add some attributes, do it right. And so it'll be in the second grid column 1, width 10, and horizontally aligned. And there it is as it should be, but it obscures the detail. So I got to go over there and give it some error on the left-hand side. The width of the splitter is 10, so I'll make this 12, and now it works. So let's try it. We fire it up, let her debug. Here it comes. Right, loading, waiting for data. There they are, and yes, we need the grid splitter to be able to see our list, and as we poke around, the companies are changing, and we're seeing in the details on the right. That's very good, so we can shut this down and give it to a real designer. As a coda to the MVVM Light sample, I want you to see that we could do all the layout you just saw me do in my preferred tool, which is Expression Blend, simply by right-clicking on the view and then finding Open in Expression Blend and launching it from within Visual Studio. And when we do that, Blend appears, and as you can see, all the design data are showing just like they should, and we can poke around in here and do all the things you just saw only using Blend. It's a wrap. Thanks for watching the MVVM Light code sample tour. I hope you'll agree with me that those 6 steps were pretty easy, especially the first 5, which went by pretty quickly, and they're all code-centric. That last one, designing the view, that takes some time and some skills, and even with the design data assisting you coming out of the design data surface, it can be pretty challenging. But the great thing about the MVVM pattern is that you can rip that view out of there and hand it off to somebody who has some design skills and really knows what they're doing with the design tools while you carry on with the business logic. I hope you'll come back and see us at ideablade.com, look at some more samples, learn more about DevForce, and best of all, I wish you happy coding.